Okay, looking at problem number 9, which is the last of the related rate problems that was asked about. We have a conical tank with an upper radius. Okay, so we have this conical tank that looks something. I want to do a better job than that. I can draw better than that. So we have this conical tank that looks like this. Okay, and it has a radius, which I'm going to label R. Let's do a better job than that too. I'm going to label that R, and it's got a height, which I'm going to label H. So this is a conical tank, and it's got water that's draining out of it. And that water is draining into a cylindrical tank. Okay. Ugh. I can do better than that. So it's draining into this cylindrical tank. And it's got a radius of, what is it? I think it's the same. So I think it's 4 meters. Now, you might be wondering, why did I call the top radius R and this radius 4? And the reason is for the conical tank, that radius is going to change. As the water drains from that tank, the radius is going to get smaller along with the height. The height's going to get smaller too. But for the cylinder, the radius is always going to be 4. That shape doesn't change. That radius never changes. So it's a constant, so I can just call it 4. Okay? So let's do a couple things. I'm going to call the volume in the water for the conical tank, I'm going to call that volume 1, and I'm going to call the volume in the cylinder volume 2. So in other words, everything in cone 1, so cone 1, the height is going to be H1. The radius, I'll call it R1. I'll call it R1 just for consistency's sake. And then for the cylinder, this will be height 2, just to kind of differentiate between the two so that it makes sense. Okay, let's see what we got. So what we want to do is we've got this water that's flowing out of this, the top conical tank, and it's flowing, what do we know? It's and it's a conical tank with upper radius of 4 meters and a height of 5, drains into a tank with a radius of 4 meters and height 5. If the water level of the conical tank drops, so notice what is dropping. It's saying the water level, that's the height. So the height is dropping at a certain rate. So in other words, dH dt for the conical, God, I don't know, I'm having trouble. The conical tank is negative 0.5 meters per minute. And it's negative because that height is decreasing. Okay? So what we want to do is we kind of want to do two things. The first thing I want to do is I want to find the rate of change of the volume of the conical tank. And the reason is that volume, when it's leaving, that volume is leaving the tank and it's entering into the volume 2, into the cylindrical tank. So those are going to be equal, right? Whatever leaves is going into the cylindrical tank. So it's important, in order to find the rate of change of the height of the cylindrical tank, I'm going to need to know the rate of change of its volume. So there's kind of two problems here. Problem number 1, I need to find, my question is, what is dV dt for the conical tank? So let's start with problem number 1, because problem number 2 will be dealing with the cylindrical tank. So let's see what we know. The first thing we know is that I have a couple variables. I have R and H and V, right? So V1, H1, R1, and I don't want all those different things. So what I'm going to do is I'm going to notice that the cone, if you kind of look at the cone, there's a right triangle here, right? That right triangle, we have the radius. I don't know why that happened. What is going on there? Let's try that again. So we have, there's my right triangle, we have this radius, and we have this height. And as the water level drops, right, it's going to be making similar triangles, right? The radius is going to change, the height's going to change, but the triangles that are produced, so if I were to make a new triangle over time, this triangle right here, this green triangle, is similar to the original triangle. So I'm going to use some ratios here. I want, in order to kind of relate R and H, what I'm going to do is I'm going to say the radius is to the height, and they gave us some numbers. So they said the radius is 4, the height is 5. So I can say the radius is 4/5 the height. And the reason I want to do that is because when I go to my volume, so now I want to set up an equation for, I want to find the rate of change of the volume of the conical tank. So for a cone, it is V equals, and if you don't mind, I'm actually going to do a couple things here. Well, actually, okay. V equals 1/3 pi r squared h. And before I continue any further, I'm just going to call this 1 because I'm going to use it in just a second. Okay, next, I can replace the r that is in this equation with the r that we found in equation 1. So I can say the volume equals 1/3 pi r squared times h. When I do that and I simplify, I am going to get, so let's do it. I get volume equals 1/3 pi times 16/25 h cubed, right? H squared times h is h cubed, which simplifies to, what does that simplify to? I think it is 16/75 pi h cubed. Okay, that's my volume of, sorry, let's call that volume 1. That is volume 1, and that is its rate of change with respect to height 1. Okay, sorry, I need to put those in. Time to go find the rate of change of volume 1. So rate of change of volume 1. I'm going to do this over to the, I'm going to do this to, no, I'm just going to keep on going the way I am. So the rate of change of volume 1 as time goes by is going to be 16/75 times third, which is this, pi h squared dh dt. Now remember, I want to find the rate change of the volume, so all I need to do at this point is replace dh dt with this information right here. So I keep on forgetting those little ones. I get dv, the rate of change of the conical cone, the conical tank, is going to be 16/25 pi h. They told us that the height was, they gave it to us when it was 3 meters. So h is 3 squared, and dh dt is negative 0.5, which is negative 1/2. Okay, which simplifies to negative 72 pi over 25 meters cubed per minute. So that is the amount of liquid that is leaving the conical cone, which also means that positive 72 pi over 25 is the amount going into cone 2. So question number 2 is basically saying, let's go find the rate of change of H2, height, right? The height 2. So in order to do that, I'm going to scroll down here. I'm going to say the rate of change of volume 2 is that number that I found before, but now that number is, right, it's going into, so that volume is increasing, okay? And I want to go find the question I want to find is, what is the rate of change of the level? In other words, what is the height, rate of change of the height? In order to do that, I need the volume of a cylinder. So the volume of a cylinder is pi r squared h. Now, I want to remind you, let's go back. R in this case is a constant. It is 4. It is never changing. And since it's a constant and it's never changing, I am going to replace R with 4. So I get pi r squared, so 4 squared times h. So simplifying that, I get V equals 16 pi h. Sorry, that is volume 2, height 2. Let's go take some derivatives. So the rate of change of that volume, dV dt, is going to be 16 pi dH dt. Plugging in our values. So what are we looking for? We're looking for dH dt. So I'm going to say dV dt times 1 over 16 pi equals dH dt. So that's the rate of change of the second level. And from here on out, I'm just solving. So let's take that equation and I'm going to move it over here, and I'm going to say the rate of change of that second volume is, the rate of change of that second volume times 1 over 16 pi equals that. So I just kind of copied that over, which was useless. So I'm going to take this thing right here, and I'm going to replace it with the number that I have. So I'm going to replace it with that 72 pi over 25. Okay? And from here on out, I'm just going to simplify. So I end up getting 9 over 50 is the rate of change in the height. So meters per minute equals the rate of change of that second height, which is what we are looking for. Actually, before I stop this, just really quickly, I know this is going to sound like a typical YouTube video, but I need to know a couple things from you. If one, if you like the video, great. Actually, I know this is going to sound weird, but please just give it a thumbs up. It's not going to help me financially or whatever. I just want to know if it was useful to you. Let me know. If it was not useful to you, please give me a thumbs down and tell me specifically what wasn't useful or what I could do to make it better for you. I did not find this process terrible, so I would like to continue doing it. If you guys find it useful, if I'm seeing that people are using it, I like to continue doing it. But if I can make changes that would make this better, I would like to know.